RAG isn't just one thing, it's two. It's retrieval and it's generation. It's search and it's prompting. And we need to treat those two components separately so we can optimize each part on its own. And when something breaks, we actually know where the mistake is coming from. And usually, you want to first worry about the retrieval before you start to worry about the prompting. And how to get the retrieval right is what we talked about in this entire series. We want to be methodological. We want to create test sets, use simple metrics, the search metrics like precision at K to measure the search quality, collect user feedback, and continuously improve our search system and optimize it for what our users are actually looking for. So we want to make sure we are actually finding the right context before we are optimizing how we present it to the model. And once we have our retrieval system working, we can start to engineer the model's context. And the second part, the generation and how to present this, is what we will be talking about today. Today we are talking to John Berryman. John worked at a lot of stations. He started at Eventbrite Search, then at GitHub Code Search, then went into GitHub Copilot. So he has a lot of experience at the intersection of like first search and now more of the retrieval augmented generation or AI driven part of search. And he recently also wrote a book on prompt engineering for LLMs. And we will be going deep on how to actually present the context to LLMs for RAG, but also in general when you're tackling a problem with LLMs. So we will be talking how to format it, like for example, using Markdown or structure finance data like SEC reports. So make it so it is a familiar format to the LLM, but also ranking information by importance or add content until the quality plateaus and then stops. So more isn't always better. And we will be looking at a lot of different mental models you can apply to your problem, how to think about prompting and presenting information to the LLMs, and then also concrete techniques that you can implement in your system. Let's do it. Why did you move from search into prompt engineering? What gave you like the nudge to move on?
Okay, so search was just a coincidence of chance anyways. I was an aerospace engineer early on, and I loved the math and I loved the software, but I wasn't geeking out like everyone else around me about the satellites. So I got into search just to get into software. And it was a pretty good fit, but all along the way, I was clawing my way back towards more math, more data science, more ML. So a few hops later, I went to Eventbrite, did their search, went to GitHub, did their search for code search. And then that project was wrapping up and I got the opportunity to jump to data science, which was where I always wanted to be in ML and stuff like that. But this hop was data science. And I found out that data science was mostly like PowerPoints and SQL queries. This is not quite what I thought I was signing up for. And then there was a spot opened on the Copilot team. And I had no idea at that point, really, what a large language model was. I had no idea how impactful it was going to be. And I was like, yeah, this is something different. It feels like ML. And I did it without any extra criteria than that. And yeah, it was a pretty good fit. It turns out search fits in pretty well in that domain too. So I get to lean back on it occasionally.
What do you think are like the processes, practices that you use the most often from search in working with LLMs?
If we're talking about RAG, everyone talks about RAG as if it's a thing. RAG's not a thing. RAG is two things, and if you keep them separated, it's a lot easier to cognitively manage the problem. It's search, and it's taking search results and sticking it into a prompt. And so the search problem is not a particularly special search problem. It's just search. So you get to use as much of search background as you like for that. Optimize search and then later optimize the prompt.
Yeah. And when it comes directly to working with LLMs, do you think like the systematic approaches from search suit themselves to LLMs as well and prompt engineering?
Yeah, sure, absolutely. So any way that you could evaluate a search problem, you can evaluate the search problem that's hiding inside the RAG problem. Because RAG problem, you're having either yourself finding the search results, or you're having the model choose to make a search. But from that point inward, it's just a search problem. There's nothing particularly special about it in context of RAG. Now, once the data all comes back, then you're optimizing how it's presented to the model so that the model can understand it and all the typical prompt engineering stuff. But it still breaks down into two different problems. It's not RAG. It's search and it's prompt engineering.
Yeah. And when it comes to prompt engineering, can you maybe touch onto the Little Red Riding Hood principle? I think this was probably my favorite metaphor in the entire book.
Yes, I'll have to give full credit to Albert Ziegler, my co-author on this one. He's really good with these little metaphors. But so if you're thinking about Little Red Riding Hood, what's the story? It's the little girl supposed to go to her grandmother's house. The mother says, you need to stay on the path. And if you get off the path, you're going to get in trouble. And so the metaphor is that whenever you're dealing with prompt engineering, if you can stay on the path of whatever the models have seen in training, if you can make your prompts mimic whatever's been in the training data, then it's going to be a lot easier for the models to understand and anticipate what's happening and to do the right thing. And for the original models, the like just pure completion models, the way this would come out would be, I just use an example. If I just type in a question like, hey, can you help me figure out how to solve this math problem? Then a likely response to that is going to be another question. It's going to be like, hey, can you help me solve that math problem? Hey, because in the training data for these original models, before they were instruct tuned and before they had reinforcement with human feedback, you didn't see this Q&A stuff. But if you could actually format the document so that it looked like something that it's seen in training, like at the top, you could literally say, this is an FAQ for this company or whatever problem space you're in. And at the beginning of the question, if you put Q, colon, and ask your question, and at the start of the prompt, you put A, at the start of the assistant, the response, you put A, colon, then this is a pattern that the models have seen over and over in their training, and they would typically respond in kind. Now, as time has moved forward, that's such a useful paradigm that these frontier models have trained them with a new type of training set. They've trained them so that with the instruct models, you have the Q&A type interface. And with the chat models, you have something that's much more robustly, this is the user talking, this is assistant talking. So I've had some people say that the Little Red Riding Hood idea, maybe that was most useful early on when we had just the completion models. But it's actually still really important, because even though the models are now lock you into, here is the user asking a question, here's the assistant with a follow-up. Whenever you present information into the model, it's still good to use motifs, patterns found from the internet, found from the training data. Write things in Markdown. Models seen tons of Markdown. If you have an idea to present to the model, like financial information, use the nomenclature, use the formatting of the C report, something that the model has seen over and over again. And that will mean that there's much less you have to do as a prompt engineer to explain all this extra details to the model, just so that it can start processing. It's put it in a place where it's used to working.
Yeah, and I think the same goes, especially in coding. I feel like you can a little bit steer the quality of the output by using certain best practices. So if you put docstrings at the top of a file, you bias towards better answers, in my opinion, because well-written code bases have the same structure, that they are well documented, well commented, and stuff like that. Mm-hmm. Do you have any techniques that you use to actually figure out, okay, which parts of my prompt actually fit into the Little Red Riding Hood principle and which do not? Or do you rather go by gut feel?
A little bit of both. I think early on, gut feel is actually going to be very important. And I suspect this will come up a few times during our conversation. Everyone says, oh, vibe testing, you can't be just vibe testing. You can't be just vibe testing. But right out of the gates, you better darn well be doing a decent share of vibe testing. You need to write in, assemble the prompt, see what the output looks like, and start like jotting down, cataloging as a human with pencil and paper, the things that are going wrong. And over time, you build up kind of an intuition for how these things can fail. You build up an intuition for how you can test them. And so slowly you're going to start, you create all these tasks for yourself, but slowly as a pattern emerges, you start firing yourself from these tasks and backing off and having LLM as judge and stuff like that. But there are other things that you can do that, and again, this is something that you should have Albert on your show to explain this bit because he did more of the research in this. But he found that you can look at things like the probabilities of the tokens and figure out how comfortable the model is with a particular portion of the prompt. So, for example, he did a lot of neat work with few shot prompts where you stick in a bunch of examples to prime the model to provide a certain similar output. And he did some really interesting work where the obvious question is, how many examples do you need before it's not worth continuing and dumping more and more examples in? And he found out that you can basically look at the average of the probabilities, not the logic. He's actually doing the exponent. So you look at the average of the probabilities. It's not quite the perplexity. It's a little bit more naive than that. But as you start dumping more and more examples into the prompt, you can look at the probabilities of the example tokens as you're printing them there. And eventually, it's a very noisy sample, but if you average across multiple iterations of this, you'll see that initially the model appears surprised, perplexed, as you start adding in these few shot examples. But eventually it levels off and you're no longer gaining any more interesting information out of the examples. Another kind of related thing to that is if you look at the initial probabilities when the model first begins its completion, then if the average of the first, 5 or 10 tokens, if their average is low, then it is indicative that the model is going to make up something. It's not necessarily hallucinate, but the model is not as certain starting out, and it's not as likely to have a good answer. It's another thing that he was able to find out.
Yeah, so this basically means that you have a lot of possible tokens which could have been taken. So you don't have a token which is a very high likelihood, but probably multiple with like a medium one or a low one. And I would expect in a few shots, I would want the model to basically be surprised or basically have a low probability for the average words when I give it input. And in the outputs, it should in the beginning also have low probabilities, but it should level off. So basically it's learning with the outputs of the few shots, like what the pattern is and how to generate it. So it isn't surprised anymore. So it has learned the pattern, how to generate it, but the inputs all the time still bring a little bit of surprise. So they actually add something new to the few shots as well.
Mm-hmm. There's actually funny. There's actually a good metaphor. I feel my own brain doing this as you're asking me questions. I'm like, how the crap am I going to answer this? And then as I talk, I'll like figure out, okay, I've got a good narrative going here. I think I'll stick with it.
Yeah. And I think like when it comes to prompt engineering, what's most complex for me as well is you're always adding stuff because that's like the easy default. But it's a little bit more about balance. Like you have to add stuff, you have to remove stuff. And this is like where the measurement comes in. But how do you actually decide, okay, when is it worth to add additional rule sets? Or when is it actually necessary to remove stuff? There is too much context or there is too little context as well.
Yeah. So we dealt a lot with this in the middle of our book. How should I tackle this problem? There's a bunch of stuff that you add to a prompt, and like maybe if we could build a framework for it for our conversation here, there's static pieces and there's dynamic pieces of your prompt. The static pieces are the things that are not going to change at all from one instantiation of this prompt to the next. Code completion would be a great example for this. With code completion, you always have the same structure, the same boilerplate that puts the code, whatever the code is going to be, allocates positions in the prompt for it. But then the dynamic stuff is things that are going to change every time. If you're looking at a new file, then obviously the bulk of the prompt's going to change. As you change position of the file, as you open new tabs, then we're gathering information in. And so a big part of the game is, especially early on, but it still carries on today, is how do you pack as much useful information into the prompt without overfilling it? Now, initially, this was absolutely critical. It was game over if you overfill the prompt. It's game over now if you overfill the prompt, but you've got 100,000 tokens. When we first started with Copilot, I think the models were like as low as 2K tokens. And so within 2K of tokens, you got to fit the context useful to make your completion, but you've also got to fit the completion as well. And the big game that you play here is how to figure out what pieces, all the content that you've gathered together. You're looking at all the stuff that might be relevant to this prompt. You've got to find some way of scoring it and figuring out this is tier 1 relevance. I've basically got to include this. And this is tier 2. It's really nice to have. This is tier 3. I'll fit it in if I get some room, but if it doesn't land in there, it's going to be okay. And so there's no one size fits all type approach to this, but when you're really concerned about overfilling the prompt, you've got to generate an engine to look at all of these chunks, consider their sizes, consider their priorities, and then usually what you're doing is you organize them by highest to lowest priority, and you take as many of the high priority things as you can until you fill up your prompt. Now, it's even trickier than that because when you're shoving the things in there, you have to make sure they fit with their boilerplate. If you've got a child that's high priority, you got to make sure that its parent is in there too. So you can't, some things are like order dependent. And so it's a real juggling act to figure out how to fit all these pieces in there. Now, fortunately, today we don't have as much of a problem with that because the prompts are so very long. You're usually not going to hit the hard wall and just stuff crashes. But you still have to be cognizant of it because the more information that you shove into the prompt, then the longer latency you see, the higher cost. And also, we know for sure that you can't just shove arbitrary stuff into these prompts because they do get distracted. Attention is a good metaphor, and they will lose their attention and not be able to as easily satisfy the goal if you just got every possible thing inside the prompt.
And is it the same for completion and chat models, in your opinion, when it comes to prompting and filling like prompt templates? And even, do you think regular completion models still have a place?
That's a really good question. When chat models first came out, I was like, they're already fixing us into a paradigm and they're closing down the options. And so I was pretty bearish on chat completions for the first month, not that long, but first a little bit, because think about what they're doing with completion models. What you're doing is you're taking the first part of a document and you're having the model figure out what the rest of the document looks like. So in principle, you can pretend to be any type of document you want. You could make it, just to demonstrate its flexibility, you could say at the top of the pseudo document, this is a FAQ, we're going to talk about this stuff, and it's Q&A. Then you've got an instruct model. You could say, this is a transcript between a support agent for this tech company, and here's the dialogue between a user and a person. And you've got the model that basically became chat. But with the chat models, they said, nope, that's all you're getting. And so initially I was grumpy about that. But it became so obvious so quickly that the chat models were going to be just super flexible. So initially at Copilot with GitHub, the completions with a completion model. I left there in May, so I don't know what's changed since then. But I've been using Cursor. I get the feeling that everybody, even for completion type experiences, is moving away from pure completion models and moving towards chat models. And surely I'm true, because basically the frontier models are almost not providing the completion models anymore anyways. So I think at this point they're very generic. They are the way that I think we should go.
I think the completion models, I rarely see them because most use cases you implement are similar to what other people are doing as well. So it's in the instruction tuning dataset what you're doing or what you want to do. So you're better off using a chat completion model. But I think there are some cases where actually using a completion model might be valuable. But I think these are more like the classical generative AI cases where you actually have to generate many options to get actually a useful one out of there. But they are way more raw, and the likelihood of getting something, a real outlier, something really interesting in there is very high. I think Linus Lee from Notion had a really cool demo on like writing, where he fine-tuned a completion model on his own writing stuff, and it got way closer to his way of writing than a chat completion model did, because you would have to train over like the entirety of what it has seen in its instruction data set so far.
It is interesting, right? You do lose some stuff when you go to chat. For example, if I really do want it to make the bottom of this document, I've got the top of the document, then one of the early frustrations we had with the chat models is that you'd have to say, now please complete this. And then it would say, okay, here's the completion of this. And then you're trying to figure out how to pick out the completion. And you've got this interim text that you don't know what it's doing to the probabilities. It's probably messing it up. And then you've also got really cool things that you used to be able to do with models that you can't do with OpenAI anymore. You can do it with the Anthropic models, but it was called Inception, another good little metaphor, where basically you start talking on behalf of the assistant. So if you own the whole completion document, this pseudo document, you can say this is a transcript, and you can start the answer for the assistant. And for example, you'd say, if you wanted your answer to be only yes or no, and you don't want this extra commentary, then you automatically start the assistant response as, if I had to say it in one word, yes or no, it would be quote, and then you know exactly how to pick out the word. But again, it's like the reinforcement learning with human feedback stuff. These models have gotten really well aligned with humans at this point, and like structured output, it's become very dependable. It was a pain in the butt initially, and so I really see it being less and less of a problem as the models get smarter and more aligned with what we typically want.
Yeah, I'm always wondering whether we are converging to the average user, or we will still get something interesting out of it just due to sheer probabilities. When maybe moving a little bit more onto like the corporate side, when you're looking at especially companies, how would you go about looking at use cases and determining whether a use case is a good fit for a LLM?
So point me in the right direction on this. Do you have any kind of examples in mind, or before I completely go off the deep end?
I want to get you in the deep end. I think that's the more interesting part.
So it's generative. There's a lot of cool things that you can do with these models that you couldn't do with like tabular ML. I still think I think there is probably an interesting asterisk on this in a second. I think that tabular ML is going to have its place for a long time. If you've got a very specific problem that you want to predict or classify or find an estimated value or something like that, for those things, oftentimes you're still going to want to use like a classical model. They're going to be cheaper, smaller, embeddable, but it's not always the case. For example, if you're doing pure numerical features, then it's probably still the case. But if you're doing something where it's like, here's a document and I want you to classify this document, that becomes much more towards LLM. It's a very generative type task. If you're summarizing, if you're providing content towards users like customer support, stuff like that's very LLM. And I could probably just keep iterating the individual things that feel like a good fit for LLM. But then if we push it too far, I think we get into tasks that LLMs are not quite cut out for yet. Basically, you are assuming the LLM is going to be exacting and super duper accurate in its responses. And so I've seen a couple of companies at this point where we're going to, code generation is a decent one. We're going to say, here is the specification for the code, and we want it to just provide the correct answer. And really, that's stuff like that is going to be super challenging to get right immediately. You're going to have to do a lot of breaking it down into workflows and tasks and steps. And a lot of these still need the human interaction. So I think there's something to be said for LLMs. If you've got an LLM task, always make sure at this point to still pull the user into it, because it's not assumed that it will always be correct at this point.
And you already mentioned like the two different types of applications, like workflows and assistants. Can you maybe quickly break down the difference between the two and when you would actually opt for one over the other?
Both are very useful in very different regimes. So to define them first, an assistant is going to be anything where the human is front and center in the loop with the avatar, the assistant. And one thing that I was just talking about with these models is I don't trust them yet to go off on their own and do whatever they want to. So you really have to have the user in the loop. And so the way that you do that with assistants is the user is talking to the assistant. And then when the assistant's like, I'm going to try this, how's this? The user can provide the correcting force to always keep it on the track. So that's how you achieve useful work with an assistant, by the human kind of correcting it and giving the assistant the tools that it needs to reach out and do interesting things. Now with workflows, you still need users in the loop. Workflows are typically something that you would have the model go and do on its own. But if you say, here's a giant task, solve it for me, come back, that's just not going to work. Instead, the way you keep the user in the loop, a different way of keeping the user's hand on the steering wheel here, is at the beginning, you have a designer for this workflow. And they say, okay, I'm going to try it and see if it works, and it won't because it's too big of a task. So then a human looks at the workflow, figures out, if I was to do this, how would I break it up into steps? And how would I make sure that these steps are as fail-safe as possible, something that ideally is not going to break? And then when there are failure modes, then how can I become aware of them and do some feedback, or maybe even still pass it up to a real human and say, I've got myself in a situation, can you figure it out? So there's I think the two main paradigms for how these things are going to work for a lot of applications. And where's one better than the other? The assistants are obviously better when you have users that want to interact with these things. They really want to keep their hands on the keyboard and direct these models to achieve something faster than they would have achieved it by themselves. Code generation, cursor, that's a great example. User support interactions is another great example. You're directing the assistant to look up information for you. Maybe I haven't personally used these yet. Something in the future that does like trip planning and can not only look up information, but actually take actions for you in the real world. That's all good stuff for assistants. Workflows is for big blobs of work that humans just don't want to do anymore. And so it would be things like scrape the web, and for each one of these web assets that comes back, perform a set of steps to glean structured information out of it. Because at the end of the day, I want to process all this stuff and have a table full of information for each website or something like that. And so those are the types of things that I think workflows are going to be useful for, streaming or batch processing that involves a lot of natural language expertise.
What are your thoughts on agents?
You put air quotes, so you're priming me to say. You're priming this conversation subliminally. No one knows what they're talking about with agents. There's no commonly accepted definition. If you ask anyone what an agent is, they make up something on the spot, as I shall do for you now. I think a lot of time when you hear the word agent, it's conflated with tool usage. And I think that's a reasonable part of it. You give a model the ability to reach out into the world and to do a thing. But tool usage, in my opinion, doesn't imply agency, because I've used tools for emitting structured content. That's gotten a little bit easier with a lot of frontier models have structured outputs right now. But one of the ways you used to be able to do that, you can certainly still do it, is say, read this and call this function to provide a structured output. That's not an agent. That's just like a question and answer. So when I think of agency, I think of it, to go back to our previous conversation, I think of it as being in this spectrum of assistance to workflows. And I feel like that is, even though it feels like two different things, I feel like it is a spectrum. One end of the spectrum, you have an assistant, which is acting as an agent on your behalf. It has its own volition. That's an important part of an agent. It can make its own decisions, chart its own course to a certain extent, but it's bounded by the user nudging it back in the right direction, saying, no, please don't empty my bank account. We're gonna watch the way you're using your tools, but it keeps it on the course. On the other end of the spectrum is the workflows, where the agent is deciding, the agent being the LLM, but also basically the DAG around it, the instructions about the steps. The combination of the LLM and the instructions about what you should do next is charting a course through some sort of space to figure out an answer. It's running into problems. It's coming back and doing stuff. And so both of these are wandering around under their own volition to some extent to solve a problem. And they do merge occasionally, because you can have an assistant that you're just chatting with a thing. It has some basic tools, but you can design them if you wanted to, so that when it gets a certain type of problem, it's, I've got a workflow for that. And the assistant can bop over into, I'm going to do this workflow. It's got a set of steps, but it's much more likely to succeed. Now, this come back from the workflow to put it on the spectrum over here, is sometimes these workflows, if they're too complicated, you could allow it the capability to reach back out to a user and say, I've got to this point of the workflow. You told me to tell you when I got here, and here I am. And so you work with me. And then you can do all sorts of mixing and matching in between. You might have a task inside your workflow that is really two agents working together. It gets a little bit risky to do that, but you can have the user proxy and the assistant. And the user proxy tells the assistant everything that it thinks I would have told it, but I don't have to be the one standing there telling it until a user assistant's like, crap, I'm in trouble. I need the real version of me to pop back in. I don't think agency is really well defined. I think it has to do with allowing these little creatures to investigate the world, almost always holding the hands with a human so that they stay on the right track.
Yeah, I would place agents above that. I think agent is something we should be striving for, not something we have right now. Because if it's getting assistance or it's well defined in a workflow, for me, this is not really agentic. Also, if I'm using an LLM to control the flow of a graph. So basically, I'm using it in if conditions to basically for the control flow where it should be going next, or making like tiny decisions. I think this isn't something agentic, because I could do the same with a rule-based systems, with heuristics, or with a classifier. For me, that's not really agency. I think we should really define agents as they are in reinforcement learning, as something that inspects the state, determines the next action, and then basically executes it and then repeats the process. And it learns over time, basically the policy, which determines, okay, when is it best to do a certain action or not.
So you have a hard definition of agency. Whereas I say, I think agents probably are still holding hands with the human, you explicitly strike that. It's like, it's only agency if they can navigate an unseen world without any humans around them and learn from their landscape and interact with it.
Yeah, because then we basically have a term that's actually usable, rather than we use agent as a catch-all term for anything that's with LLMs and uses tools.
Makes sense.
Yeah, we've talked about workflows already. In your book, you also go about breaking down problems. And you had two different approaches for that. Basically, breaking it down horizontally and breaking it down vertically. Can you maybe go into the different approaches, what they mean, and also like when do you know which to use?
Sure. Whenever you go about to set up a workflow, probably the best thing to do at the very start is to give the entire thing to the model in one fell swoop. Just say, here's the task I have, here's all the content that you might need, solve this for me, and then get back with me. And then it'll come back to you with something that looks like a Picasso. It's probably not going to make sense if the workflow is sufficiently complicated. That's when it's time to start breaking stuff down. So the first way I would usually think of breaking things down, I'd say horizontally, but it's basically the steps. You've got a workflow and you can look at this initial run of your agent and figure out where it went off the rails. And you say, okay, it's getting confused. Now, since I've, as a human, have had time to think about it more, I think that we need these 5 steps. Each one of these steps is going to be, this is somewhat of an ideal. Everything I say right now is going to be somewhat of an ideal. It's a format for thinking through it. Each one of these 5 steps is going to be well contained. It's going to have an input and an output that's well defined, like we got the schema for them, and it's not going to talk with the next step in the process. And if we are able to do that, which is a bit of an asterisk, if we are actually able to do that, then it becomes much easier to reason about. Because we don't have to say, why did this fail? And it could be for any bazillions of reasons. But we can say, rather than going on a random search through this giant space, we've gone through a guided search. And at each one of these sub-steps are effectively waypoints. And we can say, did we make it through that? Did we make it through that? We can write evaluations for each one of these little things. We can find, instead of it having just the one end result, we might find out that there's like error states or something that we just really have to account for. We can start creating this graph of instructions about if you've run into this type of error state, then go to here. And the workflow can become a bunch of steps effectively. Now, that didn't always work either. And so a different way of thinking about it is to slice it vertically. And scaling could sometimes be an issue with this too. This is still a way of thinking through it. Practicalities might still run you over when you start scaling vertically. But if you have this one task, solve the problem, but there's really 5 subproblems within it, then instead of expecting this one task to do all 5 different verticals well, you say, okay, maybe I'm actually dealing with 5 different things. I'll have some sort of task to figure out which state I'm in, and then I'll traverse down this set of steps because I'm into this special case. This is all very vague. Let me see if I can ground it a little bit with an example from a previous customer. I was working with a startup that was doing SOX compliance. And it sounds terribly boring from the outside because you have these companies that are looking at controls, these set of rules that they have signed themselves up to follow so that they provably are not engaging in fraud and stuff like that. And then auditors can come in and say, this is the rule you set up for yourself, and I can see from this evidence that you have met these rules. So that doesn't sound necessarily very interesting, but actually once we got into the problem of setting up agents to do this, workflows to do this, it was really neat because the problem does break down into steps at first and then vertically. The initial part of the problem is you've got to look at the control document, which is like the rule set. It has a bunch of attributes that must be met. And once you've absorbed the meaning from this, you can take that meaning, go to the next step, and you can say, okay, here are documents that have some evidence that might pertain to this. So you have another step that's gleaning the important stuff out of that, summarizing them, something like that. And then you can say, all right, now since we know what we're trying to find, we know about these documents that probably have pertinent evidence, pull out the evidence. Maybe you have some tools that go into the documents and actually grab cells from a spreadsheet or something like that. Find places in a PDF that you can draw a line around. And then now, since we have all the evidence, assemble a evidence report, which takes all this stuff and shoves it back together in a way that the auditors can look at later. So something that was super impossible to do in just one hit, once you started thinking through it, you can break it down into different steps that make it more reasonable, The steps can be fairly well isolated. You can optimize every one of them in isolation, but that's horizontal. You still have to do a lot of times, and I don't think they've completely solved the problem yet, but a lot of times you need to also figure out this worked really well for this very common type of audit. That's 20% of the things that we see. But there's other types of audits that if we happen to know that we're in there, then we need to specialize. We'll ask more surgical type questions because we know how to deal with it. Or this is a type of document. I've gotten to this step, and this could be a PDF with evidence, or a Excel spreadsheet, or a photo of a napkin, or something like that. For each one of these things, maybe we give it different tools. We specialize it in some way. So it still becomes tricky, because if we're horizontally and vertically doing it, then it becomes difficult to scale at some point. But at least thinking through this way is a way of making your problem something that you can approach, rather than I'm going to just throw everything at the LLM and hope it works.
Yeah, I think what would be really interesting is how do you think through integrating LLMs into existing applications, especially from the perspective of GitHub, because I think we see more and more patterns emerging. We have the autocomplete, which is basically just suggesting in a lightweight form that the user can accept. Then you have the user triggered interactions, which is either chat or even like the edit in cursor, where you basically give it a command and it executes it, and you can then review it. But you also have like automatic context gathering, which is just suggested in a sidebar. How do you actually think through the different ways how you can actually integrate an assistant into a workflow of a user in the end?
It's a very broad question. Like from a technological perspective, or we're thinking like a product perspective, like
rather a user interface perspective. So if you tackle a certain task for a user, how do you think through like how do I best use an LLM to serve him?
It really depends upon whatever the original product was. I think you'll have some products that have been begging for a long time for a technology like this. And for example, anything that has customer support in it, at this point, I think I would love to jump onto a website and know that I have instant contact to an LLM that has full access for the documentation. So you have a lot of easy, low-hanging fruit like that. But then in other things, I don't know, like code editing, for example, that's been a really interesting eye-opener. We've slowly learned over time how you need to integrate these things. People have been writing code for forever in their IDE, but we needed like the first step of, it makes sense to have something that completes the code for you. This is actually surprisingly comfortable. I don't think people realized that it was going to be a fairly comfortable user experience until we actually started working with that. And some people originally were like, that this is distracting, I don't like it at all. But I suspect they're probably using code completion at this point. And then as ChatGPT emerged, people started figuring out more and more use cases for these things as like an assistant type flow. And you can think of what workflows out there need a pairing session, brainstorming. So that's, again, with code editing, that's come up a lot. But I think you'll start to see that in other domains, like writing text, copywriting. You're starting to see this in the frontier models with OpenAI's Canvas, with Anthropic's Artifacts, where they're starting to encourage people to say, just come in here and we're going to brainstorm, pair with you, work on that thing on the right side of the screen. And I don't think, your question is very general, I don't think we're going to be to the end of all the possibilities anytime soon. One of the easiest places is not a user experience thing, but one of the easiest places to start integrating an LLM into your work is backend. As your company is getting familiar with how these things work, then start offloading backend tasks, summarization, pulling out structured content from stuff. And I think there's a lot of backstore uses for these things. And we're just going to keep learning more and more as we go, I think.
Yeah. And I'm really curious, what are to date your favorite tools where you would say this is what I expect from tools that integrate with LLMs?
Probably an obvious answer, but one that I should be ashamed to say, coming from my background working at Copilot, I really love Cursor. It's really good. It feels like one unified experience. It feels like they make it easy for me as a user to understand what the model sees. And it's actually, maybe it's even easier to just personify this. I feel more like I am pairing with a person. I can see by the way I've entered in the information, I can see what lines and more than that, what files they're looking at. I can see their thought process. When they make a recommendation for me for something to change, it's easy for me to say, I will elect that one. I will deny that one. When it's making the change, I can see this isn't LLM stuff. This is just like great user experience. I can see the red green diff on the screen and immediately know I approve this. This makes sense, and it's just a lot easier to navigate it. It feels a lot like I'm working with a human. It's really cool experience.
What would you say is missing from the space, or what is something that you would love to see built?
I haven't given any thought to that recently. I don't know. We're gonna have to edit this part out because all I'm gonna be able to say for a moment is I don't know. Let's come back to that one at the end. Let my subconscious stew on that one a little bit.
Yeah. And I think like one of my favorite questions, by the way, is always, I think like LLMs, agents are like the big trends. What do you think is like a niche, underappreciated technology at the moment that more people should use in data and AI?
LLMs is my bread and butter, and I guess search is my other bread and butter. So I'm nailing the things that people are typically thinking about right now. I've been thinking about something for a while, and I don't know if this is possibly true or not. I'm gonna answer your question with a slightly different question, a slightly different approach. But I wonder if it is possible for these LLMs to be used in place of traditional tabular AI models. So this is different from something I said earlier in the conversation, and I did say asterisk beside it. But if you have a tabular data set, bunch of numbers, bunch of features, then it makes sense to stick that into any of the traditional classification algorithms or estimation algorithms, something like that. But if you're really trying to get out not just a number, you're trying to get out answers about a space, like the horse racing stuff that we were talking about earlier, then I wonder if you could take these models and train them with all the conversations about the questions that you want to ask. So I know what the inputs are to, I know what the input features would be to figuring out what horse is going to win a horse race. I know what the input features are going to be to figure out what is the likelihood of mating these two horses together to lead to the best outcome. And you can think of all sorts of I know what the input features would be to figure out how well this particular horse would perform at a certain racetrack with a certain weather. And just think about, rather than predicting a very specific, having a model to predict a very specific thing here and a different model to predict a very specific thing here and here, what if you could train these large language models to generalize over all of that? Train it with, you got your training set and your holdout where you know the truth, and you can use that information to have conversations about what do you think. And eventually these things have shown to be able to model statistics well enough to model human speech with very high accuracy. It's surely enough flexibility in the transformer model to model this information that I'm talking about, if only we have enough data to feed into it. I've torn your original question to shreds, but That is something that I would like to research, is how well these models can generalize and be used in place of traditional tabular AI for certain categories.
And I think it uses LLMs in a context where they aren't trained in, but it uses them in a way where they are actually useful. Because it would be really inefficient to train a model on every single task you might want to run a hypothesis on. So you
Mhm.
basically use them as an engine to come up with a hypothesis and test it. And because you can come up with like infinite different combinations,
Mhm.
there is value in using an LLMs because you can do way more when they are like robust enough to actually give a useful output. It's a really interesting idea. And if people want to start building with LLMs, what are the resources you would recommend them?
Honestly, I wouldn't worry about tooling nearly as much as just getting your hands dirty with the ideas. The best thing to get started with building with LLMs is have access to one of the frontier models, grab an API key, grab a Jupyter notebook, and just start trying things. Like typically when I'm prototyping something, I'll have a Jupyter notebook open. I'll have a file in the background that's like I'm building up a library so that the Jupyter notebook doesn't get too messy. And I'll just build whatever I think is interesting, try it out, see how it works, and that will get you from 0 to 1 really quickly. A lot of the recent blog posts that I've written have been building little prototypes, and it's all super quick stuff built using that pattern. And then after you do that, then you start reaching for the more sophisticated things. You start getting into, I need to evaluate these things. I've seen 10 examples of it working pretty good. Is that really general? If I run this 1,000 times, is it really going to have the same feel? And then at that point, I think you start reaching for tools. As you productionize stuff, you absolutely have to log the prompts and the completions and all the metadata around that and start getting that evaluative feedback loop going. But initially, just get your hands dirty.
Yeah. And if people want to follow along with you and your work, where can they do that?
I recently put together a website, arcturus-labs.com, arcturus-labs.com. That's my consulting site. I've got a blog there, which it's only got 3 posts right now, but I hope to be adding a lot more content over time. I hope to keep the content pretty fun. It's going to be a lot of prototypes, hands-on stuff, things that you as the reader can use. I've actually got little embedded prototypes that you can play with. Yeah, and besides that, you can always find me in the book that I just wrote. So I hope that Nikolay will stick a little URL for that. It's all about all information you need about building applications from large language models.
So, what can we take away when we are building applications? I think, first of all, what we touched upon in the very beginning, that RAG is not just one thing, but 2 separate components. And if you keep them separated, it's a lot easier to actually cognitively manage them. And we have well-established practices and processes to actually optimize search systems. LLMs aren't so advanced yet. And I think that's another reason to actually keep them separate, because you can really focus on the search component, optimize it. And then once you have nailed that one down, you can actually play around with the LLMs way more, because you know the errors you're encountering are unlikely from the context you're feeding in, which you just retrieved. And the prompting, since it's downstream, it's very difficult to optimize it when your retrieval has a very low or mediocre success rate. And in the prompting, you then can basically try all the different techniques we just talked about. So try different formats and different ways to represent the information. And I think this often comes down to the nature of the information you're presenting, but also the task you want the model to do. I think like one mental model I always like to have is, okay, the correct answer for similar tasks. In which type of documents might the answer be, and how is this document formatted? So like for financial information, often it's like, for example, SEC documents. So you format your context like that. And also, what do you actually, or how do you want to construct the context? So if you have information that's chronological, you probably want to do something like a timeline so that the ordering actually reflects that. And this is often, it's still a very open area, and you probably won't get like an advice that it's like the solve all, but rather you want to test a lot, try different formats, and see what works best. Always test it first just by vibe checking, and then establish quantitative tests through LLM as a judge or heuristics to actually see whether there is a quantitative difference. For me, it's often like an escalation. I start with vibe checking because it's way faster, and the quantitative metrics, often you have at some point a quite large test set you want to run, so it gets more and more expensive. So I actually want to already have some confidence that this change that I'm doing to the prompt is actually something meaningful. So I'm first vibe checking and then running my test suite. And in that, since you keep the components separate, you basically also have two separate test suites. One basically for the retrieval quality and one for your LLM and your generation. And this often makes it easier to pinpoint issues. And especially for the LLM generation part, I actually often include wrong retrievals in my test set just to see how well my model handles mistakes or wrong contexts. I think what John talked about in the Little Red Riding Hood principle is very interesting, that you actually want to mimic whatever has been in the training data. And since training data is like web data to a large degree, think about, okay, how is this information represented in the web? So study common formats, documentation sites, QA forums, technical books, technical documentation, and just note basically down for your specific use case, how is the information structured in the wild, but also how could I rephrase the tasks so it's similar to a common task that is given to LLMs. So they are always trained on Q&A. But also a lot of people do like simple writing tasks or throw in a web page and ask a few questions. So often you can also rephrase or reframe the task in a way that's more suited to an LLM because it has been trained a lot on it. And also match the conventions that are present in the domain. So for finance, structured like SEC filings, analyst reports. For code, use docstrings, comments, and good patterns when you're feeding in code. For medicine, follow like the medical standards. And also in medicine, you often have different lingos or different classifications that are used in different fields. And models are very sensitive to that because they pick up on these subtle details. For legal, for example, you, depending on the task as well, you can mimic, for example, case briefs or legal memos, or really proper legalese, like you would see in the legal textbooks. I'm not sure how to say it, to be honest. And test the format variations and just see what works best. And I think vibe testing is something that has become a meme and then has become frowned upon. Now that a lot of people are really pushing evals down. For me, escalate with your confidence in complexity. So first start simple, do vibe checks. When you see it doesn't work, just disregard it. You don't have to run your tests. When it doesn't perform any better than your current prompt or it performs worse, I often think like it's not worth pursuing. When you find something that actually already shows you, hey, it has a way better performance on a few examples, then you can decide to actually run your test suites. I think one more part, which is like an important point which John mentioned, is document the failure modes. This is often really connected to your logging and monitoring, and it's actually hard to nail down, okay, when does the model fail? Since what we are doing is actually really fuzzy. It's like text we are putting out and delivering to the user. So we have to infer from the user context and what he's doing with the information we are presenting to him, whether it failed or not, and try to figure out a way how you can actually identify failures in generation. And then once you have a decent chunk of failures, you can try to figure out categories or commonalities in the inputs or the outputs, which you can put, for example, a classifier on top of to basically see whether any of them is occurring, or put guardrails in place to target specific failure modes. And I think, like, lastly, one really interesting approach he has is like he's categorizing the information he's feeding into the model in different tiers. Like tier 1 is really the critical context, which must be included. Tier 2 is like the helpful context. And then you have like nice to have context. And I think that's really interesting to talk about. It's less relevant right now because the hype is really long context models. But I think with that frame of mind, I would classify everything you're putting into the context in these 3 tiers, and then actually evaluate, like, when you leave tier 2 and tier 3 away, is the performance the same or even better because the model is more focused? And I think, like, just the frame of mind of classifying different information or pieces of context you're feeding into the different tiers or different levels of importance gives you already like hints what could you do with this information. And also, like, when you decide to actually include all of it, it also allows you to leave parts away when the length of your context window would be too long to feed into the model. But this would also mean that you're feeding over 32,000 tokens or even 100,000 tokens into it. For me, I never had the best results by just cramming the context window, but rather also optimizing the retrieval and focusing more on that, and then going for really high quality context. And yeah, I think that's most of what I would actually take away from the episode when I'm building stuff. Let me know below what you think of the episode and whether you want to have more book deep dives. For especially the upcoming season on MLOps, I've read through a bunch of different books to catch up with a little bit more of the state of the art and what people are saying, what are like the best practices. I'm also very open to do book deep dives and then after it interview the authors. Let me know whether you would be interested in stuff like that. Otherwise, if you like the episode and you're still listening to the 10-minute outro now, leave a review. It helps out a lot. Leave a comment when you have any feedback, also the critical or negative ones. It helps me improve this. When you have any suggestions on topics or guests, also let me know. Just send me a request on LinkedIn, Twitter, Blue Sky, whatever. Very happy to hear from you guys. And otherwise, I will catch you next week.